Hi everybody. So this is a video on how to use the loans formula in the finance unit for Math 154. All right. So we're going to talk about calculations having to do with loans. Now, when you think of a loan, you should think of course, borrowing money, and then you have to pay that money back. Well, in these scenarios, you're not just paying back what you borrowed, you're paying interest on the money that you still owe, okay? And so that interest is being compounded every month or every year or however often it's being compounded. And this time, we're on the flip side. We've been talking about formulas where you invested money and the interest is coming to you. You're earning money, your money is working for you. Now, we're on the flip side. You have borrowed money and now you're paying money. You're making payments and you're paying back not just what you borrowed, but also interest on what you owe, okay? And so for these, we're gonna think about things like buying a car, okay? A car loan. You pay back a car loan usually in monthly payments. We're gonna think about things like buying a house. We're thinking about large purchases where you may not have all that money at once to actually buy the thing. So you have to take out a loan to buy the thing. So a house, you would take out a mortgage loan, okay, to pay for your house. And again, you pay back those mortgage payments with monthly payments. Your college loans, okay? Your college loans eventually, maybe not right now, but eventually are gonna start accumulating interest, and you're gonna have to pay back not just what you borrowed, but also interest on that money that you borrowed, okay? So let me share my screen with you. And let's take a look at the formula sheet here, all right? So these are the formulas that we've learned so far. We've done, let me grab my red dot here. We've done the simple interest formula, okay? We've done the plain compound interest formula. We've worked with the savings annuity formula, and we've worked with the payout annuity formula, okay? So this is our last one. You have made it to the end. Congratulations. So this time we're working with the loans formula, all right? Now I want you to take a good look at this formula, okay? So let me zoom in on it a little bit. Oops, that's too much. All right, here we go. Take a good look at it. And then take a good look at the payout annuity formula, because as you were looking at the loans formula, I bet you said to yourself, hey, wait a minute, that looks just like what I just did. And it is the same format. It's the same formula, okay? What's the difference though? Why is this the same formula, but now we're talking about a loan instead of a payout annuity, okay? In your payout annuity, remember PO was the starting amount that you had in your account. Well, now we're flipping that. You're not paying yourself, you're paying somebody else, okay? So that PO isn't the amount of money you have to start. That PO is the amount of money you borrowed to start, okay? So PO, O means the original amount that you borrowed for this loan, all right? And then the D, instead of you paying yourself, you're paying somebody else. So this D now is the monthly payment, or usually payments are monthly, especially for houses and cars. But again, whatever compounding frequency you have, that's how frequently you're going to be paying those payments to pay off that loan, okay? Now, the nice thing about the loans formula is it is the easiest formula to figure out when to use, okay? If the problem involves you borrowing money, use the loans formula. Okay, there's no guessing around there. If you're buying a car and you are borrowing money and you're paying back the money, that's the loans formula. If you're buying a house and you're borrowing money and we're doing calculations about paying back the money, that's the loans formula. If it's college, a college loan and you're borrowing money, anytime you're borrowing money, okay, and you're doing calculations about how much you can borrow or calculation about how much you're paying back per month, you're dealing with the loans formula, okay? There's not a whole lot of guesswork here, okay? So whenever you're taking out a loan, use the loans formula, all right? All right. So now let's go on over to the worksheet and talk about, or write down, I should say, what the different variables stand for. Again, this is all pretty familiar to you. The only difference is that it's a flip in who's getting the money and who's receiving the money, all right? So here we go, PO. O means original amount. So this is the original amount that you borrowed. And be careful because this may be the cost of the house or the cost of the car, but then if you put down a down payment, then the amount you borrow is smaller, okay? So always think of PO as the amount that you actually borrowed. That's the number you're plugging in to the formula here. N is still years, the amount of time that the interest is being, amount of time that the interest is accumulating. So in this case, for a loan, the interest is going to accumulate on it until you pay it off. So N is the number of years that you're taking to pay back that loan. All right. D is your regular payment. Your bill, your car note, your mortgage note. And again, this is usually monthly, but it doesn't have to be. R is the interest rate. And remember, you always write that interest rate in decimal form. K is still the number of times that the interest is being compounded per year. So number of times per year. That the interest is compounded. And I want to make an emphasis here. This time you're being charged the interest. You're not earning any interest. You've just taken out a loan, so you're paying back interest to whoever loaned you the money. Okay. All right. And again, we still make this assumption. If the compounding rate is monthly, that means your payments are monthly and vice versa. Yearly and yearly, all of that. We make that same assumption that we've been making all the time. If it's not stated explicitly for one, we assume it's the same for both of them, okay? All right. So let's kind of, let's think about the investor side versus the loan side. When we think about investing money, we talked about 3 things that we wanted to have to make sure our interest was, to make sure that we were gaining as much interest on our investment as possible, okay? We said that when we put more money in, we earn more interest, we get more money out. We also said that if we leave the money in for a longer amount of time, we gain more interest, we get more money out. And then the other thing we figured out was that if our interest rate is higher, we gain more money, okay? And we also talked about the compounding frequency. As that gets higher, we gain more interest, okay? Now flip that, okay, and think about it from the borrower's side of things, okay? When you're borrowing money, you're having to pay interest. So your goal is not for that interest to get higher and higher. Your goal is for that interest to be as small as it can possibly be, okay? Because if you have to pay it back, you're paying back what you borrowed plus interest. So you want to pay back as little interest as possible, okay? So let's flip all that around. If putting more money in makes interest go up, then what would make interest go down in a borrowing situation? Well, the less you borrow in the first place, the less interest you'll have to pay back over time, okay? How do you borrow less? Well, you save up a down payment, okay? Or you save up the whole thing. There are people in the world who pay for their cars with cash, okay? You can do that. You can negotiate a price if you have that much cash on hand. And then let's think about the time. We said the longer the time is that we invest the money, the more interest accumulates. All right, well, if we're borrowing money, then we want to actually decrease the amount of time that interest is being charged. So we want to actually decrease in when we're paying back a loan, okay? We want a shorter amount of time to pay it off, okay? What was the other thing we said? We said interest rate. A higher interest rate, of course, will get us more interest. It makes that interest go up. Well, the same is true in a borrowing situation. In a borrowing situation, you want your interest rate to be low that you're being charged, okay? So everything is just kind of flipped in a borrowing situation, all right? All right, let's do some examples. Where we're making some calculations with the loans formula. All right, here we go. Marie can afford a $250 per month car payment. So Marie is going out to buy a car. She found a bank offering a 5-year loan at 7% interest. All right, so we already know a few things here. We know she is buying a car, and we know that she's going to take out a loan for it. So already we know we're using the loans formula. Bing, bing, bing. Okay. So now the first part here, the first part A, is asking how much can she afford to finance. Okay, so that word finance, all that means, guys, is you're borrowing money and paying it back with regular payments, okay? Most people can't afford to pay the big amount to buy the car in the first place, so we finance our purchase. We borrow the money and pay it back in regular payments, okay? So that's all that means. So how much can she afford to finance is basically asking how much can she afford to borrow. So when we think about our loans formula, let me write it out up here again. PO is parenthesis D, parenthesis 1 minus, parenthesis 1 plus, R over K to the power of negative N times K, close parenthesis, all divided by R over K. All right, there's my formula. So how much can she afford to finance? Thinking about the variables, how much can she afford to borrow? That's asking us to find PO. Okay. All right, so what else? So what do we know? We need to make sure we know and can plug in all the other variables in this formula. So let's figure out what they are. D is going to be that monthly payment. So she's figured out she can afford a $250 a month car payment. So that's her D. Then we have R, the interest rate. Well, the bank, she's going to borrow the money from the bank, and they're going to give her a loan at a 7% interest rate. So we see from that that R is going to be 0.07. K, all right, well, the payments are monthly. So that means K is 12. Her interest is going to be charged 12 times a year, every month. And then N is the amount of time you take to pay back the loan, or the amount of time that that you're making those payments. And the bank is offering her a 5-year loan. So they're going to give her 5 years to pay back the loan. So there's your N. All right. So now it's a matter of plugging in the numbers and working the formula, which you're pretty familiar with from doing the payout annuity formula. So the mechanics of this are actually exactly the same. The only thing that's different with the loans formula is the interpretation of the variables, how you think about things. All right, so parenthesis 250 for D, parenthesis 1 minus, parenthesis 1 plus. R over K is 0.07 over 12. Close parenthesis. To the power of negative N times K, that's negative 5 times 12. Close parenthesis, close parenthesis. All divided by, and then on the bottom, parenthesis, R over K is 0.07 over 12. All right? Now, again, you're just punching this in the same way you did for the payout annuity. So let's just take a minute and figure out this exponent first. 5 times 12 is 60, so this will be negative 60. And that way we don't have to worry about any extra parentheses there. Just do that calculation real quick first. And now I need to grab my calculator. I apologize, I forgot to grab it before we started. That's a calculator, but that's not the one I want. So let's go grab the good one that knows how to work all these parentheses. All right, let's pull it out over to the side here. Ooh. Here we go. Almost got it. All right, just trying to get it where we can see everything. And now There's our question. Okay. So, all right, the way I like to enter these in, again, is to just do the numerator first, hit enter and get that number, divide it by, and then do the denominator. If you want to enter the entire fraction all in one line, you can. Just make sure that you've got the parentheses around your numerator and then the parentheses again around your denominator, okay? So punching in what we see, parenthesis 250 times parenthesis 1 minus parenthesis 1 plus 0.07 divided by 12, close parenthesis, to the power of negative 60. Negative 60. Again, my calculator uses the minus key as the negative sign, but your calculator probably does not. So make sure you hit the negative sign on your calculator, okay? And then negative 60, and then close parenthesis, close parenthesis. Again, if you're putting it all in at once, you can just hit the divided by and keep going, but I'm gonna hit equals. And just double check and make sure you've got that numerator entered in correctly. Okay, just take a second and double check here. And if you don't, just pause the video, go back and see what's going on there, okay? So let's keep going. Divided by parenthesis, 0.07 over 12, close parenthesis, equals, and that is my PO, okay? So again, mechanically, you've done this before. You've done, these are familiar punches. Let's see, 498, so that's 50 cents. So this is the amount she can borrow in the first place. All right. All right. Part B. Part B is asking, how much total money will she pay the loan company? All right, now this is a question, please don't overthink this question, okay? What is she paying the loan company? Just ask yourself that for a second. She's paying $250 a month for 5 years, okay? That's what she's paying. So if she's paying $250 a month for 5 years, we've done this before, that means her total paid is going to be 250 times 12 months in 1 year times 5 years, okay? So again, don't overthink it. It's just multiplication. What is she paying the loan company? She's paying them the $250 a month. And so it's a simple multiplication, all right? No complicated formulas for this one. So over that 5 years, she's gonna pay $15,000 total. All right, so now remember, this amount that she's paying back includes the interest that has accumulated or accrued, we would say, on her loan, all right? She only borrowed $12,625, but she's paying back $15,000. So that extra money that she had to pay back, that's the interest. So in part C, here it is again. Don't overthink this question. How much extra money did she pay back? We have to subtract. That's all you're doing, okay? So the interest that she paid is going to be the $15,000 that she paid back minus the $12,625.50 that she originally borrowed. All right, let's do it. $15,000 minus the $12,625.50 that she's paying back. I'm sorry, that she originally borrowed. So then the interest, or the extra that she's paid, is $2,374.50. We could say that that was the cost to finance the car, okay? All right, so again, these last two questions, please don't overthink those. Don't think you have to go grab some special formula for those. Just think it through. Just think through what's going on in the situation. Think through the calculation. Simple multiplication, simple subtraction, okay? Think about what your numbers are and think about what you have to do to get the number you want, okay? If you like formulas and you want a formula, here you go. You can think of it. The interest paid is going to be equal to the total she paid, or the total money paid minus the original amount borrowed. You could say total paid back minus the original amount borrowed, okay? All right, let's keep going. Only one other calculation. Let's save this screen. All right. So this is figuring out how much you can borrow in the first place. The other thing we can do is figure out, oh, there we go. All right, come on, Dot, here we go. All right. Boop. Okay. The other thing we can do is figure out what our monthly payments will be when we're making a big purchase like this and when we're taking out a loan. This is actually pretty interesting. I have an interesting story to go with this because I actually bought a car 2 years ago, and the sales guy did not know I was a math instructor, and so every time he gave me a quote for a payment, I would actually double check his quote using the formula. And I would use these formulas to see, you know, if the calculation was, I would use these to kind of decide how I wanted to finance my car. Okay, that's basically what I was doing. I was trying to figure out how much did I want to put down, how much, you know, if I put this much down, how much is my payment going to be? If I take this deal that he's offering, how much is my payment going to be? If I take this deal, how much interest will I end up paying? And so I actually used these formulas. Now, so fun fact, when I finished the purchase and he gave me the breakdown of all the costs and everything, which is what you're going to be doing in your finance project, the breakdown of all the costs and what was included, and then the monthly payment, the number I had calculated using this formula that you're learning right now was less than a nickel off from the number that my actual car payment was, okay? So I say that to say these are not just formulas in a math book that you're learning to try to get through a math class, okay? These are real life formulas for your real life situations, okay? You can use these to help you make decisions about different purchases and what will work for you, okay? All right, So let's do this one here. Lynn bought a $300,000 house, paying 10% down, and then financing the rest at 6% interest for 30 years. So let's understand what's going on. Lynn took out a mortgage loan, okay? So she found a house that cost $300,000, but she didn't borrow $300,000. It says she paid 10% down. So that means she paid a down payment and ended up borrowing less money than the actual cost of the house, okay? So after she paid her down payment, then she financed the rest. So she took out a loan for the remaining money, and that loan, she was being charged 6% interest, and she's gonna take 30 years to pay back that loan. And that's actually pretty typical for a mortgage. They will finance it for 30 years, okay? So hopefully you heard all the numbers in there. Oh, let's switch back to blue. Hopefully you heard all the numbers in there that we're gonna use in your loan formula. But first, let's think about something. Part A is asking how much is the loan amount actually going to be? In other words, how much is she going to borrow? Okay. Now, in this case, we're not going to punch all this in to figure out how much she's borrowing. Look at this. We already know the cost of the house. Okay. We already know how much she needs. Oops. Where am I? Okay, here we go. We already know how much the house costs, so we know how much she would need to borrow. We don't have to do a fancy calculation for that. But she's not going to borrow the whole $300,000. She's paying 10% down. So we need to figure out how much money she's paying down and take that away to figure out what her loan is going to be. So 10% of $300,000. Remember how to do that. You change the percent to a decimal and multiply. And 10% of $300,000, I'll let you punch that in. That comes out to be $30,000. So that's her down payment. And so now the amount that she's borrowing is $300,000 minus her $30,000 down payment. So she's only borrowing $270,000. All right. So this is the amount that she's going to borrow to pay for that house. Okay. Part B is saying find her monthly payments. So this time we are finding D. We know everything else. So let me just, I'll come over here and write the formula again. PO is equal to parenthesis D parenthesis 1 minus parenthesis 1 plus R over K to the power of negative N times K, close parenthesis, close parenthesis. 1, 2, 3, 1, 2, 3, all divided by R over K. I'm just going to double check my formula real quick. Yep, okay, there we go. That's the right formula. All right, so let's plug in what we know. PO, we know she's borrowing $270,000. Parenthesis D, D is what we're trying to find. 1 minus, parenthesis 1 plus, R over K. And I didn't write them out. I didn't specify them up here, but let's do that now. R, remember, R is the interest rate for the loan. So that's this percentage, all right? So there's your R. Make sure you remember to move that decimal 2 places to the left. And she's taking out the loan for 30 years. So 30 years is going to be our N. And her payments are monthly. So that's telling you K. All right. And we already figured out PO, how much she's actually borrowing. Okay. So let's keep filling it in here. 1 minus parenthesis 1 plus R over K to the power of negative N times K. So 30 times 12. Close parenthesis, close parenthesis. All divided by denominator, parenthesis, R over K. All right, so here we go. We want to solve for D. So we're gonna work this backwards a little bit and unwind it to solve for D, all right? So we start by taking that denominator, multiplying both sides of the equation by that denominator. On this side, it'll cancel. And on this side, we just rewrite it with the denominator multiplied to the left side. Okay. Excuse me a second. Okay. My apologies. Here we go. So again, we're trying to solve for D. And so D is being multiplied by all of this and then divided by this denominator. So we're going to undo that and do the opposite to solve for D. So we take that denominator and multiply. And then, let me grab my pencil again. We take all of this and divide by it. And that leaves us with D all by itself. So parenthesis 1 minus, parenthesis 1 plus, 0.06 over 12 to the power of, oh, and I should have multiplied it. So this 30 times 12, you can punch that in really quickly. You should get negative 360. So negative 360. Close the parentheses. All right. All right, so this is how we're solving for D. So punch this into your, punch this guy here into your calculator very carefully. All right, and again, I like to just start with the numerator. I like to break it up. Start with the numerator, hit enter, divide it by, and then punch in your denominator, hit enter. If you want to punch it all in at once, you can. You just need to have a set of parentheses outside of your numerator. All right, so 0.06 divided by 12 times 270,000. There's my numerator. Divided by parenthesis 1 minus parenthesis 1 plus 0.06 divided by 12, close parenthesis, to the power of negative 360. And again, make sure you use your negative sign, not your minus sign, okay? And that equals $1,618.79 for her monthly payment. I'll give myself some room here. So this is her monthly mortgage payment. And that sounds about right for a $270,000 loan. Okay, let's see, her interest rate was 6%. That's a little high for the house market right now, but at any rate, you should kind of have an idea of what makes sense. A $270,000 house is a pretty decent house. And so you've got a little, a little over $1,000 for your mortgage payment every month, okay? If you do this calculation and you come up with a $200 mortgage payment for a $300,000 house, that's not that you made a mistake. You can't live in a $300,000 house for $300 a month, okay? All right, part C, how much interest will she pay over the life of the loan? All right, so this is actually the same question that we had before. Here we go. Same question we had before, but now it's just one single question instead of being broken into two questions. So the calculation is the same though. To figure out the interest, we have to take the total paid and subtract away the original amount borrowed. So let's first figure out the total that she paid. To the bank, to the lender. So if her monthly payment is $1,618.79, and she pays that every month for 30 years, times 12, times 30, okay? Then the total she pays to the lender, and I'll let you punch this into your calculator, this is going to be $582,000. Excuse me, $582,764.40. Okay, that's the total she paid. So now to figure out the interest that she paid, we have to subtract away the original amount that she borrowed. So interest paid. And remember, she only borrowed $270,000. Okay. And when you do that calculation, you get $312,764.40. That's her total interest paid over 30 years. All right. All right. So I want you to think about these numbers for a second. She bought a house. She put down a down payment. The house originally cost, or she originally borrowed just $270,000. She ended up paying, though, $582,000. The interest only just the interest came out to be $312,000. This is more than the original cost of her house. So she basically paid for her house twice. If all she does is make that monthly payment every month, month after month, for 30 years. If she never does anything else to try to lower the amount of interest that she has to pay back, then she's basically going to end up paying for her house twice. Okay? So it is in your best interest to figure out some ways that you can lower the amount of interest that's going to accrue or accumulate on that loan. Okay? All right. So that is the loans formula. Now, this last, okay. This last question in the notes gets you to think about all the different formulas that we've learned and think about them and think about the question, which formula do I need? All right, so because you won't be told that on the test. You'll have the formula sheet, but you'll need to know which one to actually grab, okay? So let's run through these. For each of the following scenarios, determine if it is a compound interest problem, a savings annuity problem, a payout annuity problem, or a loans problem. We're not going to solve. You can if you'd like on your own. All right. Marcy received an inheritance of $20,000. Woohoo! And she invested it, pretty smart, at 6% interest. She is going to use it for college, withdrawing money for tuition and expenses each quarter. How much can she take out each quarter if she has 3 years of school left? Okay, so let's think about what happened here. She took her $20,000, put it in an investment, and now she's gonna be withdrawing money every quarter. She's making regular withdrawals. She's paying herself. So this is the payout annuity. All right. Okay, Paul wants to buy a new car. Rather than take out a loan, he decides to save $200 a month in an account earning 3% interest compounded monthly. So this is interesting. He's buying a car, but he's not going to take out a loan. He's saving up money for this car purchase. So he's saving $200 a month. And here's what the interest is on the account. How much will he have saved up after 3 years? So I underlined that he's saving $200 each month because that's a key word for you to know which formula to use. Do you know? Okay. He's putting away money every single month. That's an annuity. Okay. Next one. Keisha is managing investments for a nonprofit company. They want to invest some money in an account that earns 5% interest compounded annually, with the goal to have $30,000 in the account in 6 years. So far, so good. How much should Keisha deposit into the account? So the question is asking, what should she put into the account in the first place in order for them to get out the $30,000? Compounded annually, but notice here, how much should Keisha deposit? This sounds like she's just making a one-time deposit. If it's a one-time deposit, then you're just using the regular compound interest formula. Okay? All right, part D. Meow, I hope I said that right, is going to finance new office equipment at a 2% rate over a 4-year term. Here's that word. There it is. That tells you what's going on. If she can afford monthly payments of $100, so she's paying money back to somebody. How much new equipment can she buy? So she's financing office equipment, which means she doesn't have the money to pay for it all right now, and she's taking out a loan. All right. And last one, how much would you need to save every month in an account earning 4% interest in order to have $5,000 saved up in 2 years? Here's your clue. Saving every month means it's a savings annuity. All right? All right. That's it. You're ready to go do your homework and you're ready. Oops, sorry. Here we go. You're ready to go do your homework and you're ready to review everything before your test on Unit 3. All right. Bye-bye, everybody.